presentation, but I'm going to say a little bit about it. First thing is about our hardware and mechanical and electrical design is that after 2010's competition in Singapore, we decided to change the hardware design completely so that our robots will become more agile and reliable. Then the designing of robot started and it ends just this year and about 2 or 3 months before this competition. So that the result of this change is that we made 10 robots for these competitions, but we just used 7 of them and 3 of them never gone into the field. And I think we reached our goal, which was the stability of robots, about hardware. I was keeping the hardware because the details in the ETDP are, I think, are very clear, and I'm going to the planner. Our high-level planner starts with the coach. At first, I have to say our old method and say the problems of that method to come to our new method. Last year, we had just roles and skills, and it was we used the CM Dragon's STP, if you remember, so that we had some basic skills like going from a point to another point and kicking the ball, spinning the ball. It was the basic skills, and also some of these skills come together and make roles. And each agent, we had some playbooks which contains some plays, and each play gives a role directly to agents. And the most important problem there it was that, for example, if 2 agents got the defense role, they couldn't cooperate together because they didn't have the data of each other, and it was a little hard to handle that. This year we added another layer between these layers or beside these layers, because coach can give agent to plans and plans decide what to do and which role should they execute, or give a role directly to the agents. It's, I think, beside the old plan, old method. The plans, we have 3 main plans which is using during gameplays, which is offense, defense, and middle. Defense is completely individual and controls the goalie, and defenders can have any agents from 1 to 6, and we can even defend with 6 agents very well. The middle agents and offense agent cooperate together, and there is another plan, another extra plan, which is used for when game is stopped, and we call it non-player plans. The non-player plans give the roles directly to the agents, and it depends on the signal of referee and what we have to do after that. We have written a script language, for plays that contains some. It's all. I think we invented this language, and it is exactly for a small size. In the line, the second line, you can see the referee command, which is, for example, it's our kickoff play. These are the ifs. These ifs are for getting out of this plan, and these ifs are for going inside this plan. For example, in kickoffs, we always go to this plan. if the ball moved or the game starts with normal start or forced start, the game we came off this plan and we go to offense plan in our code. There are another thing, the name after tildes or the name of plan, which is going to write on our mind. So these are roles we can give a role directly to an agent. For example, the first agent will become playmaker, and the second one will position in the field that the part of field we introduced here, and is ready for one touch. This count shows that how many agents do we have for attacking. If we have three attackers, two of them will position and one of them will be ready for kicking. If we have two, one of them will position, and if we have one agent in attack, that one will start the game. This script language helped us to make our rules and of non-player games better. And each rule have something like behavior that shows that how it works. One of our roles is a playmaker who goes to catch the ball and kick it toward the opponent's goal. And for example, there is a behavior for a playmaker. Playmaker could chip pass to our agents, or pass to our agents, or kick to the opponent's goal, or pass to defense. There are some kind of works that the agent can do. And we can change these values to make it better. Or, for example, if the pass value will be 0, we never pass to our agents. And each work has some penalty and some rewards. The first one is the reward, and the second one is the penalty. And it will calculate all of these and decide what to do after that. For example, in our last game with kicks, the passing was very much and we never kicked the goal. But at the end of the game, I think 2 or 3 minutes was the end of the game, and I took a timeout and changed the passing to 0, and we scored a goal after that. There's something else we use is this is a inside code editor. We also an editor for changing this plate inside the code, and we don't need to close it and write it again and compile it. And something else we use is the pass positioning system. Here, I think I have to show this at first. We wanted to take a position in this left, the wrong left, and we use some algorithms, and there are so many factors like the openness of the agent who wants to start, and the openness from ball, the angle of the agent, the distance from other opponent agents, and there are so many factors. And calculating this by CPU was very hard, and it took many times. So that we decided to use CUDA and use GPU for that. And the result is here. Exactly for this image, the result is here. You can see that in front of the ball is black, and we can't stop. In front of these two agents isn't good place, so they are dark. These angles are very hard to kick, so we don't stop. There are so many factors. Among our goal is very dangerous to get a pass, so we want to stop. And after that, after generating this picture, we will search inside this arrays for the best position with a very simple image processing program. And for this picture, the result was here. And the result GUI. Then we have another thing, the plotter that can plot the data of the book. And that's enough.
Any questions for Zephyr?
When you change your script, you don't have to recompile, right? That's good. That's very good.
There are some text files, and each time after a stop, it will read all the text files together and choose one of them. Oh, one thing I forgot to say about these plays. You can see a number here, a value. Is how likely is to choose this play, and it is between 0 to 1. And for example, we have 4 or 5 plays for example, indirect in one place. It will calculate a random number and considering these numbers, we'll choose one of them. And after that, after executing each of them, it depends on the success or failure of this plan. The number will decrease or increase. And one thing that helped us in these games was game with MRL, that we detected they had something that the agent would come very fast, run back and kick the ball. We detected that and wrote a play for that to stop exactly in front of that agent. So that at the first one I put the value here was the value I was put, it was I think 0.5. After 2 or 3 in the rest for them, it became 1. And after that, all the time, the agent would stop there to stop the agents.
Any other questions? Okay, thank you.